Okay, chapter 15, amines. Amines and amides. Chapter 10 and 11, we looked at just two elements, carbon and hydrogen. Maybe a little bit of halogens, but predominantly carbon and hydrogen. Chapters 12, 13, and 14, we added oxygen. Carbon, hydrogen, and oxygen. Chapter 15, now we're adding one more element, nitrogen. So it's supposed to have been carbon and hydrogen, oxygen, and now carbon, hydrogen, oxygen, and nitrogen. Nature likes nitrogen, likes all those molecules, all those atoms. But you're going to see the importance of nitrogen in biologically active molecules. Importance of nitrogen and oxygen. So don't let me downplay them, but as we get to amines and amides, you're going to see this coming up in amino acids, in DNA, in nucleic acids, etc. Nitrogen. What is an amine? An amine is a nitrogen that has some organic substituents on it. Here's a methyl and a hydrogen. The amide functionality, which we'll focus on this for 80% of this chapter, and then we'll mention amides. You've got a carbon-oxygen double bond and a carbon-nitrogen on that carbonyl. The carbon carrying the double bonded oxygen also has a nitrogen attached to it. That's an amide. Antihistamines are drugs that depress the release of histamines. So when you see amine come up in a name of something, methamphetamines, they're amines. Histamines, they're amines. So what are amines? Amines are organic derivatives of ammonia. So we're dealing with ammonia here. The starting point, that's not an amine, that's ammonia. It's not organic, doesn't have any carbon on it. So it's an inorganic molecule. Let's remind ourselves a little bit about ammonia and nitrogen. Nitrogen is in group 5A on the periodic table, which means it has 5 valence electrons, which means it can bond, can share with 3 other things, shares an electron with 3 other things, and it has an octet of electrons around it. And this is ammonia. Doesn't bond to a 4th item, at least right now. We'll see something here a little bit later. But it doesn't bond. It's got a lone pair of electrons there, 2, 4, 6, 8 electrons around it. It's fine. Carbon has 4 valence electrons, bonds to 4 hydrogens. Oxygen has 6 valence electrons. It bonds to 2 hydrogens. All right, so the nature of the element and what it is seeking in the way of an octet of electrons is driving this. We got NH3, ammonia. So an amine is an organic derivative. What's that mean? You take off a hydrogen and you add an organic group of some sort, and you've made an amine. Classification of amines. So here's our ammonia molecule with a nitrogen with 3 hydrogens on it. Take one of the hydrogens off and add take one of the hydrogens off and add a methyl group. I said, where'd the other hydrogen go? We got a methyl group here. Carbon with 3 hydrogens. Still has two hydrogens here, nitrogen, methylamine. Take off another hydrogen. You get two methyl groups on it, one hydrogen. You got dimethylamine. This is a primary amine, secondary amine, tertiary amine. Amines are classified by the number of carbons directly bonded to the nitrogen atom. All right, so you got an example there of primary, secondary, and tertiary amines. Let's see, what was I going to say about that? Yeah, let me just. So let's take this name right here, methylamine. Let's pretend we don't see that molecule, which we don't anymore. Methylamine. All right, now we know from what I just told you a minute ago that nitrogen likes three things around it. So let's go from the name. The name is methylamine. So let's put a methyl group on here. It only mentions one methyl group. So what are the other two positions going to be taken up by? Hydrogens. Okay, so what I want to help you figure out here is, how do I write the structure, for example, of methylamine? There it is. If I give you the name dimethylamine, start from the same point. This is what nitrogen is going to look like. It's going to have three things around it. I got a methyl here, and I have a methyl here. The hydrogen isn't mentioned, but I know it's going to have three things around it, so when I draw the structure of that, I'll draw a nitrogen with two methyls on it and a hydrogen. That completes the structure.
Does the geometry of where they go matter?
No. No, that could be right here. The structure of it here. Yeah, here's your ammonia. You know, it doesn't really matter where those are. They're all. This is like a pyramid. Ammonia is like a pyramid. So if we had a methyl group coming down here, you just rotate it around. It'll get into that position or that position. Doesn't matter how you draw it. Yeah, you could even draw it with, you know, a methyl on one side here and a methyl on the other side here, and a hydrogen down there. Sounds like the hydrogen's in the middle, but it's not. There isn't any middle. They're equidistant away from that nitrogen. Trimethylamine, you know, trimethylamine, you just know you got, that's all you have on there. It's three methyl groups. Trimethylamine. Okay, let's classify these as primary, secondary. We won't name them right now. We will pretty soon. Yeah, we probably could name them. But top one, primary, secondary, or tertiary? Look how fast you learn. Next one, primary. The secondary, primary, tertiary amine, secondary. Secondary. We've got this on there, and we've got a methyl on there, and one hydrogen. So this is a secondary amine. All right? Did you get all those? Did you? No. Oh, he's honest. You got it now?
Sort of, like, I get the primary, and then I'm just a little confused on the tertiary.
Tertiary. Where's a tertiary? Here's a tertiary. Yeah, look at that, Jacob. You've got an ethyl group over here. That's this. You've got a methyl group up there. And you've got a 4-carbon chain right here. All right? No hydrogen. There's your 3 things around it. So that's tertiary. That make sense? Okay. Okay, nomenclature of amines is going to be a little bit of a challenge if you're like any of my other classes. All right, so I'm going to make some provision for that and also some recommendations. The one thing that complicates it a little bit is there is a common way of naming amines, or simple amines. Simple amines can be named with a simple name or common name. We're going to look at these right now. But there are 2 IUPAC conventions for naming amines. I'm going to favor one of them. And the book will give you, a lot of times the book will give you an amine, and it'll give you the 2 IUPAC names of that amine. So some amines can have 3 names. How can we simplify this? Here's how we can simplify it. If it's simple, give it a simple name. And don't worry about what the IUPAC name of this would be. We can go and look at that, but if you can name it simply, I wouldn't worry about an IUPAC name for it. If it goes beyond simple and we got to use IUPAC, then I'll show you the one way I favor. The other thing here, the provision, is that if I ask you to name an amine, I will accept any one of those names that is a correct name, whether it be IUPAC or common name. Just has to be an accurate name. Talking with one of my other colleagues, if another chemist would know what amine you're talking about, then it'll be taken correctly. All right? I won't be giving you a question like, what is the IUPAC name of this amine? I'll just say, what is the name of this amine? And you name it. Chemists would, if you called this by its IUPAC name, most chemists would tolerate it, but prefer you to use its common name. Okay? 99% of the time, they're going to use that name. Maybe in a publication, if the journal says, they want everything in IUPAC names, that use the IUPAC name, but for conversation, for communication, generally speaking, they wouldn't use the other name because chemists would have to think about it. What are you talking about? Oh, you're talking about methylamine. Why didn't you call it that? Okay, follow me? So here's simple names. If the substituents on there are methyl groups, ethyl groups, propyl, isopropyl groups, whether there's one, whether they're the same thing, 1, 2, 3 of them, or a mixture, you got a methyl and an ethyl, just use a simple name, ethyl methylamine. All right, trimethylamine. You got a tertiary amine, and you got 3 methyl groups on it. Ethyl methylamine, you've got 1 ethyl group, you got 1 methyl group. and you've got a hydrogen on there. So, that one looks like this. It's got a hydrogen, it's got an ethyl, it's got a methyl, so, the list goes on. You could have diethyl methyl amine. Okay, what you can't have is diethyl dimethylamine. All right? It's got 4 things on there. We will see something later on, but we're going to change its name. We won't get there yet. All right, so these are simple. Keep it simple if it's a simple amine. All right, if it is not a simple amine, now we got 1, 2, 3, 4, 5 carbons here, and we have an NH2 group on it. Oh, you can see right there, I can't just call that pentylamine. It's ambiguous. It's not specific enough. If someone did refer to pentylamine, I would assume, but I wouldn't like to assume things like this, that the NH2 is on the end. Pentylamine. But here is a 1, 2, 3, 4, 5 carbons, and the NH is on the second carbon. So what are we going to do here? Go back to our IUPAC naming. Find the longest chain. 5 carbons long. That's called pentane. We're going to treat the NH2 group as a substituent. NH2 is an amino group. It's an amino group. So now we're saying, okay, where is it? It's on the second carbon. 2-aminopentane. All right, here's one where precedence is given to the alcohol. So the parent name is propanol. Since the parent name is propanol, that makes this carbon number 1. All right, we're going to number the carbons based on the functionality that we've rolled into the parent name. 1, 2, 3. So it's 3-amino-1-propanol. There's 1,3-diaminopropane. So you can use the diamino, triamino, etc.
You gave us a convention for naming, and you said there's 3 parts. So this would be the first part, an amino, and if there was an alkyl group, that would go second, and then the base name.
Yeah, right. All right, Steen is asking, okay, yeah, let's say we had a methyl right here. Say we had a methyl right there. So then it would be 2-amino-4-methyl pentane. Yes, good question. Okay, so amino, hydroxyl, bromo, chloro, this is going to be up in front. It's not going to be bunched in with the alkyl groups. It's going to be up in front. Right. Good question. I'm not sure I got an example there. Yeah, alphabetize it with that. I think that's the way you would handle that. I don't think we'd get real particular about that. So you have 3 parts to the name: the miscellaneous things, the alkyl, and the parent name. Yeah, good. All right. We'll come back and look at this. You can see this in your. You can see here's where they're using an IUPAC name for something that's just methylamine, propylamine. This was 2-aminopentane. This is what I'm saying. These are 2 IUPAC names. 2-aminopentane is what we had just on the previous slide, and another IUPAC convention is to drop the E on the pentane and add the word amine. But now you have to put a number in front of it. It's 2-pentanamine. So these are both IUPAC names. And this is the one that I'm saying default to that. That's my suggestion. Default to that. If I say, what's the name of this, or what's the name of this amine, and you can't give it a common name, then you can default to this amine, this here. Treat it as NH2 group as a substituent. Okay. And that is enough for today. I will get into this on Tuesday or Monday. I'll get into this on Monday. Why do we use an N? When do we need to use an N in names? And we'll carry on in chapter 15. Chapter 14 will be due on Monday.